All right. So I have one sign in this problem. What would you do first? Sure. Okay, so 2 sine 3x equals negative rad 2. When I subtract it over and then divide by 2, sine of 3x equals negative rad 2 over 2. Okay. Now what?
Make 3x like theta.
Okay, so we can solve the simpler equation and solve sine theta equals negative rad 2 over 2 first. All right, and there should be 2 of those on our unit circle. Where does sine equal negative rad 2 over 2? We are in radians, by the way, in this problem. 5 pi over 4? 7 pi over 4. And these problems where you replace the angle with something else are where you want to include the plus period times k. So in this problem, it would be plus 2 pi k because it's a sine function. The only ones where it's not 2 pi are tangent, cotangent. All right, once I have theta solved for, what do I do?
Change it back to 3x.
Change it back to 3x. 3x equals 5 pi over 4 plus 2 pi k. 3x equals 7 pi over 4 plus 2 pi k. And then to solve for x in both of those, what do I need to do? Divide by 3. You could also think of it, because you're not going to have a calculator, as multiplying by what? 1/3. Imagine multiplying everything by 1/3. So it's going to be x equals 5 pi over 12 plus 2 pi over 3k and 7 pi over 12 plus 2 pi over 3k. And then to get answers, we're going to have to add on 2/3 to 7/12. So this is where we said it's optional, but you could rewrite that 2/3 with a common denominator of 12ths. So 2/3 is the same as 8/12 there, and that might make the next step a little bit easier. Okay. So answers between 0 and 2 pi. First one is 5/12. And then if I add 8/12 to that, I get 13/12. And if I add 8/12 to that, I get 21/12. And if I add 8/12 to that, I get 29 over 12, which I know is bigger than 2. 24 over 12 is 2. Then I go to the next group, 7 pi over 12, 15 pi over 12, and 23 pi over 12. Anything after that would be larger than 2 pi. You could always subtract it too, because k is an integer, it could be negative. But if I subtract 8/12, it's not going to give me any additional answers between 0 and 2 pi. Okay? Any questions on that one? Next. All right, same sort of procedure here. Angle's a little different. Okay, but we're going to get the function alone to start. So I'm going to get my secant alone. 5 secant x over 2. If I add 3, I get 10. If I divide by 5, I get 2. And then I don't love secant, so I could change it to what? Cosine. Just make sure to make the 2 a 1/2. And then if you think of that x over 2 as a theta, it's going to be similar to the last problem now. We're going to solve for theta first and then put our x over 2 back in. Where are 2 places in radians where cosine is a 1/2? Pi over 3. There's one more. 5 pi over 3. I replace the angle, so I want to make sure I say plus 2 pi k. Plus 2 pi k, period times k. Put x over 2 back in. And then in both of those, how do I solve for x? Multiply everything by 2. So I'm going to get 2 pi over 3 plus 4 pi k. And I'm going to get 10 pi over 3 plus 4 pi k. So those are all the answers. Now I just need to figure out which ones are between 0 and 2 pi. So definitely 2/3, 2 pi over 3. If I add 4 pi to that, it's going to be too big. If I subtract 4 pi from that, it's going to be too small. So that's all I get from that one. 10/3 is already bigger than 2 pi. So 10/3 is not an answer. If I subtract 4 pi from 10 pi over 3, what's that going to be? 10/3 minus 4. 10/3 minus 4/3, or 12/3. It would be negative, right? So that's not going to be between 0 and 2 pi. So we actually only have one answer here. Okay on that one? All right. Last one. Okay, so they're both cosine, but it's different angles. Okay, it's not like where we can factor something out if it's a squared function, if they're different angles, and you have two functions like this, the only thing we can use are the sum to product identities, which remember all 4 of these are going to be on your formula sheet with your blank unit circle. All right, so we want the one that's cosine minus cosine. Let me grab mine here, make sure I use the right one. Okay, so this is the one that starts with a -2. -2 sine, and then it says to add our angles in the formula, and then sine again, and then I subtract my angles. All right, so the first one's going to be 3x plus x over 2. Second one's going to be 3x minus x over 2. Whole thing is still equal to 0. If you want to at this point, you can just say, I'm going to divide both sides by that -2, and the -2 is just going to end up canceling. So I divide the left by -2, it's gone. On the right side, 0 divided by -2 is still just 0. So -2 doesn't do anything. If I simplify a little bit, I have a 4x over 2, so just a 2x. And then I have a 2x over 2, which is just an x. Yes? You can keep it there if you want to, but only a factor that has a variable in it is going to give me a solution. And there's no variable in it. So what I didn't, I mean, it looks like it's canceling, but what I did is divide both sides of the equation by -2. Okay? To get it to go away. Just simplify it a little bit. All right, so now we turned it into a product. If you have two things multiplied together to get 0, that means one or both of them equals 0. So as soon as it's a product, you can split it into the two pieces. And now both of these you're going to solve independently to get our answers. I'm going to start with the one on the right because it's actually a whole lot easier. The angle isn't weird. Where does sine equal 0? Between 0 and 2 pi. 0 plus 2 pi k, right? And then there's one other place where sine equals 0. Pi plus 2 pi k. All right, those are all the answers for that one. That's it. The one on the left, the angle's a little weird. So I'm going to replace it with a theta. I'm going to solve for theta first. Now, it's still sine equals 0 here. So theta is going to equal 0 plus 2 pi k, and pi plus 2 pi k. And then I'm going to put the 2x back in. 2x equals pi plus 2 pi k. And then you can imagine either dividing by 2 or multiplying by 1/2. So I'm going to get x equals 0 plus pi k and pi over 2 plus pi k. All right, so 1, 2, 3, 4 things that are going to give me answers. So now I've got to figure out from those 4 what are all the answers between 0 and 2 pi. I'm just going to do one group at a time. My first answer is 0. Plus pi is pi. Plus another pi is 2 pi, but we want 0. We don't want 2 pi, so I'm not going to write 2 pi down. That's all I get from the first group. Then pi over 2. If I add pi to that, I get 3 pi over 2. If I add pi to that, I'm bigger than 2 pi. And then on the right, 0 I already have, pi I already have, plus 2 pi k isn't going to give me any extra answers between 0 and 2 pi, so you have 4 answers. This is the one where you can get a lot of solutions. I think a couple of the ones we put on Polaris have like 8 or 10 solutions. So if you want to see one that has a few more answers when the period gets a lot smaller, I would encourage you to like try a couple of the ones that are posted online before Monday, okay? And that's it. All right, so you've got 7 solving problems on Monday's part of the test. The rest of the period is yours now to just look over things on Polaris, ask me questions, whatever you want to do. Monday we'll do the test, and then actually Monday night you're going to watch a video starting our next lesson. Okay? You can always watch that ahead of time if you want to. It's online. All right, I'll do cell phone lotto. Any questions for me? No, nada? Sounds good. Maybe.